Right, so we got some electrical stuff here. Now, this battery, I used to have this battery alongside this one here, which we're going to take a look at, in a pack like this. You can see that I have the positive and negative soldered together, and if we take a look on the voltmeter at, for example, here, I'll take this, so we go positive right there, and we go negative right there. So we can see around 2 volts. These are, I believe, 1.5 volts, but what happens is you use a battery, they will go down in voltage. Now this is a 3 volt light, I believe, and if we just put it like so and we flip the switch, there we go, see that? We get the light working. Similarly, if I put my motor to this battery, see that? Now that works a lot stronger than this battery, which, as I said, it's dead, but what does dead really mean with the battery? Because we're going to figure that out. Here I've got it connected to the voltmeter. Now is that really dead? We're getting about nearly 0.8 of a volt. So what does it mean when these alkaline batteries or any lithium, whatever, goes quote unquote dead, it doesn't have enough voltage to power whatever it's trying to power. But if we have something that's fairly analog like this motor, which will take any voltage, even under a volt, what happens? See that? It's hard to see because of the light, but we're getting a little bit of movement. Very difficult. Ooh, there we go. See that? Coming off this, what, about nearly 0.8. Looks like we've got, yeah, there we go. Yeah, about 0.8 volts. So, if you can take electricity out of a battery, you should be able to put it back in. Now these should say somewhere non-rechargeable. Do not dispose of in a fire. Please insert and correct pole. Look, if I had the cardboard thing which had all the batteries in there, it'd probably say non-rechargeable alkalines, right? So why are they non-rechargeable? I'll show you why they're non-rechargeable. You see how there's like a plastic O-ring. Now that's actually, there's an entire kind of plastic cap, and then there's a metal cap which is the positive, and that, I mean the negative, and that's being protected or grounded, I think, against the shell of the battery, which is technically the shell of the battery is the positive, the zinc positive. And then there's a plastic cap, and you've got that little hole, see that hole there? And you've got this other hole around here. Now, if you recharge these at too high a voltage, so what happens when you recharge, you're simply just putting back a little bit more voltage than usually they have. So this is a 1.5 volt. You'd put like 2 volts, maybe 3 volts if you're trying to do it really quick. But the problem is they build pressure and they leak, because these are alkaline batteries, which means there is a hydroxide, like a maybe a sodium or potassium hydroxide fluid. You can see here, maybe there's some like bits of moisture, like this little water droplets, because inside of this battery, firstly, the negative has this little nail, which was very silvery, a strong silver color. It could be made out of silver, it could be made out of zinc, I'm not sure. And inside there's 2 different kinds, you're probably not going to be able to see it, but there's 2 kinds of powders. I think the outer powder, which is the black one, is like a manganese dioxide, and the internal, maybe it's like a zinc, it's like a bluey kind of powder, metallic powder, and they're both saturated with this fluid. Because I was thinking, you know, what a waste, because there's all this metallic powder which hasn't even oxidized, hasn't even converted back. And why are we wasting these batteries? Why are we wasting all the chemicals inside them? Why not just recharge them? Because all the chemicals and all the powder inside his battery, if I can maybe get some out. Not really. I've got a tiny little bit of a... I don't want to open this up because it's, there you can kind of see, yeah, see all this stuff is, you know, still in there, and it's still functioning fine. So why are we wasting them? Why are we, you know, it's so ridiculous. And it's because, of course, you know, because that's how battery producers make money, by getting you to buy lots and lots and lots of these, by making them so they don't have a very long shelf life, so making them that you can't recharge them. But what if we made our own rechargeable batteries, or what if we modified these, or, you know, a bunch of other what ifs? So here is a 12 to 24 volt battery charger, and you can see there's multiple modes. It's on lithium. There's lithium, there's lead, you know, lead 20, I think it's 24 says here. There's lithium iron phosphate, which is like the new ones, and there's a repair mode, which is a pulse mode. Now I use the pulse mode here, which basically goes from about 16 to 24 volts. It just keeps going up and down like a pulse. On this here, this old, it's probably like, I don't know, 15 years old, I'd say. And if we put the positive to the positive here, all right, positive, positive, and negative, negative, we're getting a, here we go, I was holding it wrong. So we got up to 9 volts, which is not bad. Now these, you can see, because it's spilt, you can see all around here, it's kind of, I think it's crystallized these salts here. You can see the spillage range from these things here. You can open them up and, you know, add more liquid if you need to, and you can see the water level, I think around there. Well, that could just be the lead level, I'm not sure. Anyway, so what I did, I put this pulse charger on, which if we just go the negative and to the positive, it does that. See, it starts to go slowly up and down. And if we look at the voltage, for example here, we just put that in like so, and we go the negative like so. Look at that, it's pulsing it. And that's one way to, just take this off, to kind of repair and fix a battery. Now what happened is that I left it on for too long, and that's why it leaked. So I figured out that if you put too much power, and if you do it too quickly, that they'll leak. Now, for example, if we go back to the lead mode, and I try to charge it, put these back on, it says off, oh wait, DES, and okay, so that works. Let's go back, put these to figure out the voltage, for example. We can see we're getting a lot of, what are we getting? 12, okay. Yeah, getting about 12 volts. So it's basically charging it. It seems to be charging it at 12 volts. So it does say full, but it is still putting off a current. So you can see here an 11.6766, and it's slowly going down. These just ambiently go down. Of course, there's power going into the voltmeter, I think, so that's going to drain it. But it shows that, you know, this can, even though it's like 15 years old, it can still hold a voltage, essentially. So now from the experiment, that essentially this battery is just like a zinc shell with some kind of, here, if I can find that, you go, a little nail essentially inside of it, which is, I don't think it's touching the shell. and it's touching some electrolyte, which is a hydroxide, basically, yeah, the electrolyte solution, the metallic paste, as you can see here. How about we test making them? We could use this metal container, and the container itself could be the positive or the negative, and then we could have the positive and negative as this piece of copper or this piece of metal. You know, there's all kinds of things you could use. For example, I mean, this piece of metal as well, maybe. Of course, it depends on the like the voltage differential chart. Which, for example, one second. Here we have the anode and cathode, as you can see here. The most cathotic, the most anodic. And the best anodes are magnesium, as you can see, in magnesium and zinc. These are always used. Now, aluminum, we've got a lot of aluminum, cast steel, etc. And then it goes down to around copper. You can start using, so you can use copper and aluminum, that's a decent one. Maybe lead, aluminum, silver and gold. Platinums are very good as the cathode, I think. So we can see cathode, platinum, gold, silver. Why is platinum, gold, silver always, you know, so valuable? It's a very strong cathode. Then magnesium, zinc, aluminum. So basically you can use a metal from there and a metal from there as the anode and the cathode. Admittedly, lead batteries, I think they use it as both lead, but whatever. So the idea with the battery is that it's the difference in voltage between the metals. That's how you get a power. That's you get a power from there. And adding power or taking away is just like, you know, it's like reverse electrolysis or electrolysis, as we might see later on. Copper has like a, I don't know, like a 0.5 or something, and aluminum's like a 0.7. So you should be able to get like at least like a 0.2 or something off the difference of these. And I'll show you that when you add the electrolyte, essentially, that's when it starts to, you know, you start to get an effect. So we'll try that out now. All right, so what we got is the central positive electrode, or positive or negative. We'll figure out which it is. I've got salted water. Now you can use magnesium salt. I just use regular sea salt. Magnesium is good for a lot of things. You can use that for lead acids as well. And we got foil, which hopefully it's electrically conductive and non, you know, finished. And we got plastic wrap. And my idea is to have plastic wrap as like a body, then to put foil. Then I'm going to use what we got is, so I'm going to get plastic wrap, tissue paper that's wet with the salt water, and then I'm going to put this here, and I'm going to have the foil on the opposite side. Foil doesn't touch the copper, and the plastic is just to kind of keep it in. So I'll set the camera up and I'll make it and show you what it looks like. Firstly, we need plastic wrap. So this is an insulator, which is good. And then secondly, we're going to use this foil, which is aluminum foil. Alright, so you can see we've kind of got this. Now, I think I want the aluminum foil a little bit bigger, or actually that should be fine. Okay, and then we want to wet this a little bit, because this is going to be our like electrolyte. Ideally, I want a dry electrolyte. If I can find a dry one, I know there's crystal cell batteries that I want to look into. They're like semi-dry electrolytes. That would make things a lot easier. And now, what should happen between, you know, put this, that's why I left on this little bit of plastic here, so that they don't touch. Now we'll wrap it up like a burrito, I guess. So that's got to be like that, so it doesn't touch. I'll kind of wrap the bottom up and wrap the sides, just to make sure nothing, you know, nothing touches, because otherwise we short it out. And then I'll start to wrap this up like so. I've probably made it a little bit too big. I think I'm actually gonna chop this in half. Like so. Yeah, probably a bit easier. And I'm just going to wrap it up like a... And this is kind of similar to how batteries are actually made. They're wrapped up, but you've got two sheets of metal. And that's good. So we should have our positive up here, or negative. I don't know which. We'll figure it out. And then we have our other one down there. So there we go. That's it. That is. I mean, the basics battery. We could add metal powders in the middle to, you know, to put our positive to the copper and the negative to the aluminum, and we get, okay, yep, we get in a second. Let me show you this on camera. Look at that, nearly 0.7. So okay, so that's our positive, which is an anode. I think that's the anode, and this, or wait, no. Apparently aluminum is meant to be the cathode. I don't know. I'm not sure. Whatever. We'll just say that's positive and negative, because it seems to be how the voltmeter wants to work it. Okay, so we're losing. See how we're losing current to this. Now, can we power our motor? Let's see. So we get our positive hooked up to the positive, and a negative hooked up to the negative. And we get nothing. But what we can do is I will get my DC generator and I'll try to power it up, and we'll see what we can do while powering it. We can also make a bunch of these and hook them up in series, but I want to see how many volts this will work with. You can see it's causing it to beep. I'm not sure why. Alright, so you see I've got it around 3 volts. I've got the positive to the positive, negative, negative, and hopefully that will cause some kind of electrolysis to happen inside of here, as long as it's not shorted out. Looks like the amperage just went up, yeah, by quite a bit. I think when I'm smushing it together, the amperage rises. I think that's getting more surface area. Maybe if I think that's why they use the electric paste, because amperage just dropped. Now let's turn it off for now. And what are we getting? Let's see, let me stab that in and get that down there. Look at that. Look at that. We're getting a 1.2 volts off this, and we'll take the clips off. Could be losing power. Look at that. We're literally getting 1.4 volts off this piece of junk, essentially. This piece of copper wire wrapped in a piece of toilet paper, wrapped in a piece of foil, wrapped in a piece of plastic. Because what's happening here is we are electrolyzing. One of them is being electrolyzed. We'll figure it out. I'll unwrap the battery in, like half an hour or so after it's kind of, it's done its thing, and I'll figure out which one is being disintegrated into its oxide. Supposedly when you use them a lot and there's more powder and all that, you get more amperage from it. So we'll see if that works as well. Okay, so I've had this charging for about 20 minutes, 30 minutes probably actually, and let's connect it to this a little more. Okay, well, it did technically go up. Technically. Oh no, actually I think it was the same. Whatever. I have made 2 of them. I've made a second. Now what happens if I put this in series, which basically means negative to positive, which should give me more voltage. I don't think it's going to double the voltage, but it will, maybe give me more. Or maybe get up to like a volt. So let's check negative, positive, and look at that. Actually, it did double the voltage. Oh my goodness. Isn't that cool? You see there, 1.4. So yeah, I could just make a bunch of these and keep doubling it, I guess. I'm going to need more wiring. Now, can we power anything out of this? This LED should only take about 2 volts. I'm not sure if this is enough to give it, to make it work, but
let's see if I can get. Oh, I got a. I think did I get a spark off that? No, I don't know. Sounded like I did. Can I get anything? No, because I don't think it has enough amperage to power anything. I think that's the issue. Yeah, we're getting nothing. So we're still on. Yeah, still getting that much. Yeah. So what I want to do with this one is I want to open it up and try to show you if there's been any electrolysis. And there should be, like, yeah, as you can see, you can kind of start to see like that blue. So that means the copper is the one that's been like affected chemically. And that's how this works. This electrolysis, reverse electrolysis procedure. Okay, how do we do this? Yeah, I can smell it. You see how that's all blue? That's because, I don't know, I'll try to open this up. Give you a better look. I can smell. It smells, I don't know, weird. Almost a little bit funky. I guess copper. Yeah, copper's, what's down there, so to speak. Okay, you can see there that the copper has been. There we go. You can see that it's got all that copper. What would that be? I don't know, copper oxide, copper, yeah, something like that. And that's what's when you use the battery, that oxide essentially is what is being reconverted to copper, I think, when you use it. And then when you can see it's kind of dark there a little bit. And then when you recharge it, it's being turned back into into the oxide again, I guess. So, yeah, that's interesting. Alright, with the help of ChatGPT, I figured out how to read amperage using a multimeter. Negative there, you can see, and a positive there, and it went up to about 80. It'll probably go back up to there, so it's 80, and you can see it's on the 200, so it's milli amps supposedly. 80 on the 200 milliampere section of multimeter indicates 80 milliamps, or 0.08 ampere hour. You can see this here, 2.2, or about, 1.8 to 2.2 volts for those, 3 volts for those, and 220 milliamps. I think if I connect enough of them together, it should work, so I'll give that a shot. Just a quick note on reading amperage. So I think usually when you read voltage, this terrible lighting, excuse that, you read voltage, you put it on the voltage section here. Instead we put it to the amperage, and here we have these two symbols. I believe that's DC and that's AC. DC, and then bottom of the wave I think is AC, and you can see down there it says MA or 20A. So depending on if you're working with milliamperage or 20 amps, 200 MA max or 200 amp max. I don't have up to 200 amps, so we're just working with milliamps. Now this is the other battery that I made that I didn't charge, and if you look at the amperage, we're getting, look at that, 2 amps. So you can see charging it enhances the amperage that it can produce. Well, if I turn it back to voltage here, voltage 0.6 volts, and you can see voltage drops, amperage rises seemingly. It seems when you connect a circuit that the amperage slowly starts to rise while the voltage slowly starts to drop, which is an interesting thing. So I need to charge this basically, and the idea is that it seems that when I charge it, I mean, usually the voltage is meant to go higher. This one doesn't seem to be, but whatever. Either way, I'll need to charge it, and I'll see if I can get that LED running. I just wanted to show you I'm making a smaller version. I got a small piece of foil here. I got a piece of tissue paper and a little bit of plastic wrap, and then we just pop our thingo in like so, and we basically just roll it up like a burrito. Now, a better way could actually be to like get all the tendrils of the wire and like wrap it in different areas, because we got all this space that's just that, and it's not really doing anything. Doesn't really matter for now, but just, you know, for later, or if anyone wanted to make their own. And then of course we just kind of crumple it to make sure we don't short circuit anything, and then just wrap it in this paper here, in this plastic, just to act as a, again, so we don't short circuit things. Alright, so what I've got is, I've got these all in series, see positive, negative, etc. And I'm going to hook it up to the voltmeter and show you, because I'm going to charge them all like this, and we get about a 1.8, which is pretty good, 1.85, nearly 2 volts. And amperage wise, we got nothing. We basically got nothing, which is fine because we haven't charged them yet, because we want that amperage to at least be at 20 milliamps to get that LED running. So what I'm going to do, I'm just going to wire it up the charger, and I'll show you, and we'll charge them up. Okay, so I've got the copper hooked to the positive and the aluminum to the negative. I can see aluminum's kind of like the sheath, like the physical, and the copper's like more the spiritual, I think, the positive, you know, being a golden metal, so it's, you know, it's internal, so like that. Hopefully that works better. I don't really know, you know, I'll have to test it out another time to see if another way works better. So I guess it's all experimentation. But anyway, I'll leave that for about half an hour and wait until it's got some amperage. 18 milliamps, and voltage we are getting about, oh my goodness, 3 volts. Just after charging it, we're getting about 3 volts. Ooh, steadily declining. I'm going to first test the 3 volt light we have here, because I don't want to blow the 2 volt one. If I have too many volt, you know, if it's just a volt over, it'll blow. So let me just quickly hook it up, and then I'll show you. And would you look at that? I just hooked him up, and look at that. I'll turn the switch off. All this part's just a switch. You can forget about it. Look at that. It's dull. It is dull, but it works. So I'm going to put my positive to check voltage. And 1 second. So we're getting, voltage wise, we're getting 2.6. And we're lighting up. Look at this. It's not attached to anything. Isn't it amazing? It's 3 of these little batteries here. If I put a 4th in series, let me just get my cable, we should get a stronger light. So let me just quickly do that. All right, look at that. That's a bit of a stronger light, I think. I've got all 4 of them, and I'm gonna connect my multimeter here. So we got voltage wise, we're looking at okay, it's still 2.6. Well, that's weird. Maybe this one lost charge or something. I don't know. Or maybe something is acting as a resistor, or it's just not drawing. Maybe it's just not drawing enough power. Whatever. Anyway, what I'm going to do, I'm going to hook up maybe 2 of them to one of the smaller lights and see if we can get that going. 2 is enough to power this small light. It's not big, as you can see there. I'm going to turn this. You can see that. Now I'm going to hook up 3 and show you that. We're getting like we had about nearly 0.8. So that's a bit stronger. I've got 3 of them hooked up now. Or even 3 is a bit, oh, it's a little stronger, but it's still kind of weak. So I've got this green one. It's very dull. It is working, but it's very, very dull. I'm going to see if, firstly, let's check the voltage. So we're still only getting around that. I'm going to put a 3rd and see a 4th, excuse me, and see if I can get the thing to go glow a bit bigger. Still not really glowing that much more with the 4th. Test the amperage because I'm still getting a tiny amount. Right, so we're sitting on 2 amps. So that's like 10% of what we had. Basically, I think I've
burns out most of the charge, which is all right. But yeah, it works. Isn't it awesome? I'll charge it up again. Yeah, you can see amperage is just dropping. I'll charge it up again, and we'll see what we can do.
So for closing thoughts, there at the end there you could see I had about 3 volts and about 9 milliamps, and that was after charging it. I tried to charge it at 12 volts for like 10 minutes to see if it would speed it up. It didn't really seem to charge it too much. It was pretty slow, but you know, it was a test. I definitely want to know how to get these to hold more of a charge. I think if I can do that, because realistically they hold like half a minute at least for, it's like 30 minutes of charge time for half a minute of, you know, holding charge. I mean, I could just tape a bunch of them in parallel and get a lot more amperage that way. That is one way, but it's a little bit impractical for like what, maybe I'll get up to 10 minutes of LED light. I don't know. There's got to be better ways to do this. I'll have to research the physics more, but I think it was fun. Is this something you can try at home? If you have a multimeter, a battery, like a 12-volt battery or a DC generator to charge it up, you could even just use, you know, 1.5-volt batteries, and you got maybe some tape and wire and, you know, foil and LEDs, and you can try it yourself and figure out how to do it. It's pretty. I think it was pretty fun. I'm looking into electrolyteless, you know, like the gel batteries or the solid states and the crystals and all that, to understand those, because people are getting pretty decent results, and the crystal batteries at least seem to basically recharge themselves. Like they drop voltage wise, but they seem to just keep recharging, which is really cool. So I'm kind of interested in that. But otherwise, yeah, it's really cool. I'm amazed it worked. It's incredible. And here I have the battery. So what I did is I taped like the positive to the negative. So basically, you know, put them head to foot, so to speak, or head to butt or whatever, and tape them together, and then I taped the whole thing together, and I got a positive and a negative electrode. So I basically got a, you know, I think it's like a 2.6 or 2.8 volt battery here, and it's way too big. It's way too big for what it does, but you know, I could definitely get it down size wise. I think there's a lot of work to do to get that down. Anyway, I hope you enjoyed, and I hope you kind of understood battery physics a little more. My objective long term is to create a battery that, you know, basically just doesn't run out and can power small lights, because I think it's such a waste that we just throw away these alkalines, or at least modify the alkaline, because I mean, as I said, there's so much, like the chemical, the metals, the metal chemicals, they just don't get used up and they just get thrown out. So it's really not a good thing environmentally, just, you know, even for our money and all that stuff. Anyway, of course, have a good day, and feel free to check the links in the description if you're interested for social and commercial things, and goodbye.